This Zoom session is being brought to you by the fractal squared circle. All right, for today, we'll be covering trigonometric equations and trigonometric identities. Trigonometric equations like sine x equals a, or cosine x equals a, or tangent x equals a. And there are various refinements on that and so on. The idea is that this is true for some, but not all values of x. And the question is for which values? Okay, when sine of x equals a, well, when does that happen? Well, here's a sine wave. Here's the line y equals a, and here this is where x equals arc sine of a. Here's arc sine of a plus 2 pi, then plus 4 pi, 6 pi, and so on, plus and minus 2 pi times an integer. X equals arc sine of a plus 2 pi n for n, a whole number. Then there's this, symmetrical to this. Here's 0, here's pi. So this is forward a distance arc sine a. This is backwards a distance arc sine of a from pi. So it's at pi minus arc sine of a here. Then here is at 2 pi minus arc sine a plus 2 pi plus 4 pi plus 6 pi and so on. Okay, so sine x equals a for x equals arc sine of a plus an integer multiple of 2 pi, or x equals pi minus an arc sine of a plus an integer multiple of 2 pi. For cosine x equals a, here's a cosine wave. Here's y equals a. This occurs at arc cosine of a. This occurs at minus arc cosine of a. And then you can add and subtract integer multiples of 2 pi. So cos x equals a means x equals arc cosine of a plus 2 pi n, or x equals minus arc cosine of a plus 2 pi n for some integer n. Now, to solve tan x equals a, well, here's a graph of tangent. Here's a graph of y equals a. Here's a solution, arctan a. And because it doesn't loop back the way these do, it's just going to be this family of it. So it'll be this plus, and then here's a period pi, plus 2 pi, plus 3 pi, minus pi, and so on. So the solution will be arctan a plus some integer multiple of pi. So we have this. So for example, now here we're going to, some of these they ask for solve on the unit circle for theta between 0 and 2 pi radians. Okay, so here, 2 sine x plus 1 equals 0. Solve that. All right, first transpose the 1. 2 sine x equals -1. Sine x equals -1/2. Okay, now, one way to solve that geometrically is we draw the unit circle. And since sine is -1/2, we draw the line y equals -1/2 and see where it meets the circle. It meets it here and here. Now, okay, I could talk about a negative angle, but this is asking for theta between 0 and 2 pi. So there's this angle here, and then there's this angle around here. So a break back angle and a packing angle. Now, all right, here and here we see a triangle with radius 1, this side 1/2. This is going to be the 30, 60, 90 triangle. This is root 3 over 2. So this is pi over 3 radians here. All right, so we could have this be, let's see, and you can think of this as angle as pi over 3 radians. So you can think of it, this angle here, the 270 degrees, minus pi thirds, or this angle here, 270 degrees, plus pi thirds. And so this is 3/2 pi, plus or minus pi over 3. And okay, and you add it up, and it's 7/6 pi, or 11/6 pi is theta for this one. Now here, again, we're going to have to solve on 0 to 2 pi on the unit circle on the first rotation. 4 secant theta plus 6 equals -2. All right, so transpose of 6, 4 sec theta equals -8. Divide by 4, secant eta is -2. Now this is a secant, what we need is the cosine, but all right, so the reciprocal of secant is cosine. Take the reciprocal of both sides, and cosine theta equals -1/2. So okay, we draw a unit circle, and here the x value is -1/2, so we draw this vertical line at -1/2. We want this angle here, an obtuse angle, or this angle here, a breakback angle. This angle in the middle here is pi over 3 radians, 60 degrees. So we're going to have 180 degrees plus or minus 60 degrees. Pi radians plus or minus pi thirds. And that will be, okay, 1 plus or minus 1/3, 1, it'll be 2/3 pi or 4/3 pi. Solves this. 4 cos squared equals 1. Solve that again on the unit circle. All right, cos squared equals 1/4. Therefore, cosine is plus or minus 1/2. Plus or minus, watch out. So at plus 1/2, here's this. At minus 1/2, here's this. Here are the 4 solutions. This is at pi thirds. This is pi minus pi thirds. This is pi plus pi thirds. This is 1 full rotation, 2 pi minus pi thirds. Pi thirds or pi minus pi thirds or pi plus pi thirds or 2 pi minus pi thirds, which comes out to pi thirds or 2 pi thirds or 4 pi thirds or 5 pi thirds. Here we have 2 sine squared theta minus 1 equals 0. All right, so 2 sine squared equals 1, sine squared is 1/2. Sine is plus or minus 1 over root 2. Okay, those imply 45-degree angles. So here it is positive 1 over root 2. Here's negative 1 over root 2. We have this angle, this angle, this angle, this angle. This is on 0 to 2 pi. We want this angle here, or this angle here, or this angle here, or this Pac-Man angle here. This corresponds to pi fourths. This corresponds to pi minus pi fourths. This corresponds to pi plus pi fourths. This corresponds, and this one corresponds to 2 pi minus pi fourths. And that gives pi minus pi fourths is this, pi plus pi fourths is this, 2 pi minus pi fourths is that. So theta is pi over 4, or 3 pi over 4, or 5 pi over 4, or 7 pi over 4. Now here we have solve cosine theta equals negative 1/2. First solve it on the unit circle, and then give all possible, including wraparound solutions. So we're going to add, here we're going to add the 2 pi in. Cosine 2 theta is minus 1/2. So 2 theta is, well, plus or minus arc cosine negative 1/2 plus 2 pi n. Okay, arc cosine of negative 1/2, well, that corresponds to 2 pi over 3. So 2 pi is plus or minus 2 pi over 3 plus 2 pi n. Now here there's a bit of trickery, because this is 2 theta. So we have to divide by 2, and theta is therefore plus or minus pi over 3 plus pi n, not 2 pi n. So that's the general solution. Because of this 2, we have a pi n rather than a 2 pi n. Okay, and then if you look over the possibilities, you'll get pi thirds plus 90 degrees more than that is 2 pi thirds. 90 degrees from that is 4 pi thirds. And then 90 degrees from that is 5 pi thirds. So there you go. Pi over 3, or 2 pi over 3, or 4 pi over 3, or 5 pi over 3 in the unit circle. Here we're getting kind of cute. This is a quadratic in the sine. 2 sine squared minus sine theta minus 1 equals 0. Okay, so this is really, first we have to solve a quadratic, and then we have to solve a trig equation. Now, a few steps short, this polynomial in sine factors into 2 sine theta plus 1 times sine theta minus 1. You can also solve for sine by the quadratic formula, whatever. 2 sine theta plus 1 equals 0 means it's negative 1/2. Sine theta minus 1 equals 0 means its sine is 1. So we draw a unit circle and go up a distance 1. And that happens just with this one solution. Or go down minus 1/2 to find these 2 solutions. And this is at 90 degrees, that's pi halves. This is at 180 plus 30 degrees, which is 7 pi over 6. This is 360 minus 30, it's 11 pi over 6. These are the solutions. Here, here, and here.